In this tutorial, we'll learn how to use the Average Word Vector plugin for the Butter text analysis software. What this plugin will do is take your texts and then quantify them in terms of their average semantic vector. Now here's an example of a word embedding model that has already been trained. And you can see that each line has a word and then a vector that corresponds to the semantic space or the semantic placement of each word. So what this plugin will do is take a text, go to each word, look it up in this pre-trained model or whatever pre-trained model that you choose, and then get the vector for each word and then calculate the average vector for each word that has been detected. Now you can use pretty much any type of pre-trained vector, or you can train your own vectors ahead of time using the Word2Vec plugin within Butter. But for this example, I'm just going to use this one that someone else has trained from the Tassa corpus. Now also for this example, I have this data set of TED Talks. And so just to reiterate, what this plugin will do is go through each word or token, look it up in the pre-trained model, and then get the vector. And then across all of the words that it finds in the text that are located within our pre-trained model, it'll get the average vector. So if you have a, for example, 300 dimension pre-trained model for some corpus, then each text will be the average 300 dimension vector. Now let's take a look at what this looks like. So first, we'll go ahead and read in our text files. Then we need to tokenize our texts. So we'll use the Twitter-aware tokenizer. Then we connect the Average Word Vector plugin. And when we go to the settings, we see there's really only one main thing that we need to do, which is select the model file that we want to use. So I'll go ahead and choose this here, and you can see because of the format of this model file, it already fills in some of the basic information about the model itself. Now typically you'll want to choose a model file that's appropriate for the type of data that you're analyzing. So for example, if you have a model that has been trained on the New York Times or newspaper articles, it may not be as applicable or work as well for something like social media data as would a model that has been trained specifically on things like people's tweets or Facebook status updates. Now from here, we just choose where we want to save our output, so we'll connect this plugin and choose our output location, and we'll just call this Butter CSV output Tassa, because that's the name of the model that we are using, or I should say the model was trained on the Tassa corpus. Now we run this plugin. It's going to take a little bit of extra time to initialize this because it has to read in that Tassa model file, which isn't too big. This model is only about 570 megabytes or so. Now once it's loaded in the entire model, it will be able to very quickly go through each text and then get the average vector of each text and then save that output later. Now you'll see a little bit more once this finishes how you can usually use this or how people often will want to use this. Typically what people will do is use these vectors to calculate how similar two texts are to each other, or to do some kind of text clustering, for example, to identify different texts that seem to revolve around the same topic. Ultimately, there are a lot of different things you can do with this, but the typical way that it's used is to use some metric like cosine similarity or cosine distance to take these vectors and then calculate the degree to which any two texts are similar or dissimilar from one another. And we'll go ahead and cancel this. We don't really need it to finish all the way. Now let's take a look at what this output looks like. So here you can see we have the name of each text. We have the number of tokens in the text. Remember, we tokenize these ahead of time. And we have the number of tokens that are captured by the pre-trained model that we're using. So for example, in this case, the majority of words in the text were able to be matched up to some word in the model that we have. And you have a better fit between the model itself and the type of text you're analyzing. Usually you'll have a pretty good match here. So here we're matching well over 75% of words in the text. And then for each text, you can see we have this vector that has been quantified. So this is the average of the vectors for each of those detected words, all the way up to 300. And so if you want to know how similar two texts are, you can calculate the cosine similarity between this vector and this vector, for example. And that's it. That's how you use the average word vector plugin for Butter.